Okay, in this part of this video, I would like to discuss further about the BlockMesh that we have previously used to construct our lead-driven cavity case. But in this part, I would like to explain the detail about how to set up the coordinates and how to read the boundaries. And also, we will make some modification about the mesh, so we will not make just a simple block, but we will make this geometry which consists of 3 blocks and make our simulation a little bit interesting. So the first step, of course, is to copy and paste the previous folder. We can do the copy paste inside this WSL, or if you are using Windows, of course you can copy and paste it from here. But a simple tip for me, if you want to make your search faster, you don't have to go here and go here every time you want to go to the project file. We can pin this to the quick access, so we just simply click here. Of course, it's not a mandatory, just like simple tips to make your life easier. And we will copy this file, this trial one, the cavity, but we still have some files here, so we must delete from the projects. And trial one, cavity, and we remove it by using the foam list times -rm, and we can copy this. Actually, you don't have to delete that if you want the result, but we don't need that, so to save the space it is preferable to delete it first. Then we paste here. Then let's say it is the trial 2. So before we edit the mesh, I will give you some basic idea about the format of the block mesh. So if we let's say we check this block mesh, basically this block mesh is a collection of coordinates like this. So the coordinates started from 0 because it is like the consequence of the programming language. So the numbering is like this: 0, 1, and so on and so forth. So the confusion sometimes is arise from this numbering because it is started from 0. So the block mesh works like this direction, so you must always aware about the direction of the mesh or the direction of the vertices. Let's say from 0, 1 it is in the x direction, and 1 to 2 is in the y direction, and so on and so forth. So if you make your geometry, let's say, in the different system coordinate, you must make sure that it follows this numbering. And 0, 1, 2, 3, the 4, 1 must be in the z direction or the positive z direction. So the 0 is the lowest part and the most left part of this block mesh. So I hope you get the idea. And if you notice from the simple block, the 0, 1, 2, 3 has the same x and y coordinate as the 4, 5, 6, 7. So if you notice, it is only differ in the z coordinate. So sometimes it is easier just to copy this and paste here. Then you just change the z coordinate. Okay, then the next script is the blocks. So the blocks is basically creates the block itself, as its name suggests. So the block consists of 1, 0, 0, 1, 2, 3 up to 7. So like this, you must follow this direction, orientation. Then this scripts indicates the resolution of the mesh. So if we use like 50, 50, and 1, it means that the 50 blocks in the x direction, then 50 blocks in the y direction, and like 1 block in the z direction indicates that it's a two-dimensional problem. Then for the boundaries, we define it by the surface. So this face, let's say the 3762 is basically like this, 3762, the moving wall here. So the numbering comes from this number, so you must always stick to this numbering. 3762 means that 3762. It must it is not mandatory to follow this orientation. Let's say you can write it like the 3267 or 2673. It's basically the same, as long as you are not like make a cross orientation like 3627. It will not works. Then the other also work the same way, like the walls, like the 0473. This is the leftmost wall. The 2651 is the rightmost wall, and the F1540 is the bottom wall. So I hope you get the idea. It's also the same for the front and back. So that's all. That's about the BlockMesh. And maybe we also want to make the modification to create these more interesting blocks, let's say. For more complex geometry, before going to that, you must understand that BlockMesh is not always like rectangular blocks. You can make the pyramid, not always have to parallel and perpendicular to each other. So if you want to make a skewed blocks, it is also possible using this BlockMesh. But during this tutorial, I will maybe use these blocks. And the understanding of constructing the blocks is very crucial, because you can construct lots of problems by using these blocks. And not only a square, we can also make like a triangle and also the circular BlockMesh, but maybe we will discuss that for the advanced topics. And again, BlockMesh is very crucial, because if we want to make some blocking for the snappy hex mesh, the basis or the basic construction for the mesh is also the BlockMesh. So yeah, you must understand this. And let's just make this block by creating this. Of course, you can edit it using the Nano, but it is more convenient to edit it using the Notepad, in my opinion, for this kind of task, because we just can simply copy and paste. Okay, let's just make this by first making the 0, and here I put like the 8, 9, 10, and so on and so forth beside the 0 and so on and so forth, because we can see that the difference is only in the z direction from the last because this I hope you get the idea. Okay, let's just make the 0, then 1 is 100, then 2 is 110, 3 is 011, I mean 010. Okay, then go to the fourth number, and again I must emphasize that the start is from 0, so that's the common mistake the learner makes. The fourth is 1, -1, and 0, so the y coordinate is the -1 because it is underneath the 0 coordinates. And 5, so we make the translation to the x direction in 1 meter, so the x will be 2 from the for the 1. and number 6 is the 200. Number 7 is 210. So we only need 7 vertices, and the other we just simply copy and paste here and simply change the z coordinates. Actually, you don't have to like edit the numbering system like here to 8, 9, 10. So the double slash, it means that it's just like a comment, so you don't have to worry about the number here. Okay, this is the first step to define the vertices. Then we define our blocks, which is which are the 3 blocks, consist of 3 blocks of hexa. So first we define the 0, 1, 2, 3, 0, 1, 2, 3, then 8. So please be careful here because we make the irregular list of the vertices. Then for the x direction, let's say we just want to like a 20. So yeah, that's it. That's the first blocks. Then the second block, let's say this one. So we use the 1, 6, 7, 2, and 9, 14, 15, and 10. The orientation not have to be like this, but it is very crucial to follow just like this to make sure that the the resolution of the mesh is simply defined. And one thing that you must make sure that the orientation of the mesh in the direction of y here for x1, x2 must be the same because they will be connected. And oftentimes students just like a mistake by setting the different resolution in the y direction or in the x direction for the hex2 and hex3. So you must really careful about this, because if the resolution of the neighbor mesh doesn't match, they will like simply become error. And it is also true for the grading, which we'll discuss later about making the like non-regular mesh like this. So each block has to be connected to the neighborhood. Okay, let's go to the third blocks, which is the 1, 4, or maybe we start from 4, 5, 6, 1, and 12, 13, 14, 9. So just make the resolution the same, so we don't have to worry about that. But if you want to make this resolution different, let's say this y of the hex 1 must be the same as the y in the hex 2, and the x of the hex 2 must be the same as the x of the hex 3. I hope you really careful about that. So then we go to the boundaries. It is a little bit tricky because we have more than one blocks here, and you must define the face for each block. So you cannot define the connected faces. Let's say if you want to define the top face of this, you cannot do like the 3, 7, 15, 11. Instead, you must define it one by one, like the 3, 2, 10, 11, and make another line 2, 7, 15, and 10. So I mean 15. So you must be really careful about defining these faces, because we must define our blocks. And for this block, we cannot make it like this. Let's say I will make just a simple example. So if you want to make the block like this, it will not work because it is not connected. So you must consider the connectivity between blocks. Again, yeah, that's the consistency is the most important thing that you have to consider here. Okay, let's go to the next step to define the leftmost wall, which is 3, 0, 8, 11. You don't have to follow this orientation, but you know, as long as the numbering is correct. Then for the bottom one is 0, 8, 9, 1, and 1, 9, 12, 4. Paste again. Then 4, 5, 13, 12. You must be a little bit patient about his. And 5, 6, 14, 13. But I hope you follow this step by step because it will be a followable hands-on experience for you. And 6, 7, 15, and 14. Here we go. And the front and back. 1 is 0, 1, 2, 3. It is the back. We make the back first. 1, 6, 5, 4. 1, 6, 5, 4, and 1, 6, 7, 2. It is the back. Then we also create the front, which are the 8, 9, 10, 11. Then 9, 14, 15, 10, and the last one is the 12, 13, 14, 9. Yeah, I hope we get no error here because you know it is the moment of truth. Just go to the back again, go to the trial 2, cavity. Wait a minute, did we just edit in the trial 1 or trial 2? Oh, it's okay, I think it's right. Just check to make sure. System blocks. And yeah, I guess it's right. So just try to run the BlockMesh. Oops, we made a mistake here. Directory console polymesh BlockMesh point label 1 for 15 out of range on patch front and back. Let's just check the front and back here. Front and back. And luckily in this OpenFOAM we got the you know, like the error and specify which line is error, so it is very helpful. And the front and back 0, 1, 2, 3. Wait a minute, let me just check. Point label 1 for, oh, it is 1. I just need to give the space. Run again, and here we go. Touch foam.foam. Let's check. It's the moment of truth. Okay, let's just drag and drop here to check the mesh we've just created. Foam.foam. Make sure the time is correct here, and here we go. Our BlockMesh. And before we run this, we must make sure that the patch are correct. Let's say the moving wall is the top one, and the front and back are the planes. Then the fixed walls are the walls. Oh, wait a minute. Are the walls around this. So yeah, everything just defined. Then we just can do the foam run. and wait. Okay, it is finished smoothly with 2-second finish. Then try to touch again the foam.foam and reload the file. Now let's make sure to click the internal mesh again if you want to fully complete the visualization. Then go to the last time step to see the velocity, let's say, and here we go. We got our velocity. Or maybe we want to check the streamline. We can use this slice to the Z direction. Then I can use this feature, the stream tracer, but maybe okay, it's like this is okay. Just apply. Then here we go. We got our streamline. Maybe I will reduce a little bit about the number of the lines so we can see it more clearly. Maybe 200 is fine with the other coloring scheme like the solid color. Here we go. It's our new case with new blocks. And we can also display the mesh here, even we are using the slice. Sorry, must change the slice, and here we go, our block mesh.